Okay, so before we start, I want to say thanks to the organizers. They did an amazing effort to collect out this lineup of speakers, excluding me, of course. So thank you for attending this talk. Some quick presentation. My name is Guglielmo Iozzia. And currently I work for a company called Optum, which is part of the United Health Group, which United Health is probably the biggest health insurance company in the United States. Optum is a tech branch, and I'm based in Ireland, and I'm coming from previous experience in IBM in Ireland as well, and before FAO, which is an agency of the United Nations, which headquarters are in Rome. This is just to cover the last 10 years of my career. And my current fields of expertise at the moment are big data, machine learning, deep learning, and DevOps applied to these spaces where there are new ways to die in production. So if compare this to traditional web application or other standalone application. And I'm no more a developer. My current role is much more responsible for how people deploy things and which technologies use for their project and other stuff in terms of financial things on people management, etc. But in Optum, every person is a tech person, so it's not uncommon to speak with some senior director and having IntelliJ in his laptop, downloading some Java Scala project and speak about technical jargon with him or her. So that's good. And I'm coming from experience as a developer for the JVM languages. So far we're Java, Groovy, and Scala lately. And then I moved to test automation, CI/CD, in particular applied to cloud application before moving to the big data machine learning space. And there is a book upcoming in December for the guys of Packet Publishing. That's the cover there. Basically, it's part of the experience, my experience and my team's experience on using Scala and some available framework for Scala on top of Spark in terms of making some models ready to run in production. So not just a theory. And I love cooking. That's one of my favorite food. I used to do homemade pizza. Unfortunately, there are no tools facilities to do this, but if you are in Dublin sometimes, you're my guest. So, by the way, that pizza had a short life cycle because my wife and my daughters finished it before I could. I had just a picture, so I don't know if it was good or bad. As I mentioned before, I'm based in Dublin, which probably is the most challenging tech hub in Europe. So there are all of the IT tech giants have offices there. Google, Amazon, Facebook, IBM, Optum, Oracle, many others. A lot of startups, so lot of innovation events. And by the way, my company is hiring, so if someone is interested in some relocation in Dublin, just contact me after this. So the main topic of this talk is about why Scala for data science, because there is a misconception. People think about data science, about big data, machine learning, and say, oh, we do this in Python, but they don't consider other languages, while Scala probably is the more powerful, and you have the same facilities you have for Python language. So I will go through the very basics of the deep learning, because that's important, because if you want to move to apply Scala, your Scala knowledge to some deep learning matters, you need just to understand the theory, then you will see it's very easy to move to this space. And a quick overview about Apache Spark, but some other speakers did some other hints, so I will go very fast on that part. Then I will present the core concepts and libraries of DeepLearning4j, which is a library that has been meant to move the JVM to deep learning. So the final J is not for Java, it's JVM, so there is support for Scala. And some concept that we'll see with some example. The ID crashed, but we'll go through the code anyway. So, if you have in mind to do something in data science, or in particular something for machine learning or deep learning, so you can use Scala. So I suppose everyone here in the room is very skilled about Scala. So to me, a big advantage you have if you use Scala in this space is that your experience or your skills can be brought to this space. So if you think of all of the things you have done so far in terms of scalability, resiliency, performance, concurrency, they apply here, because most part of the tools using big data and machine learning have been implemented in Java on Scala, so they run in the JVM. So the same problems or issues you have addressed so far apply here, so the same skill you have, you can apply. So to me, this is a vantage point from a person coming from Java or Scala to the big data machine learning, rather than a person coming from Python, because some concept in terms of performance and scalability are quite alien to them. There are plenty of frameworks available for this. Some people believe I use Python because there are a lot of libraries for statistics, for numerical computation, for machine learning. This is true, but it's true for Scala as well. I put a short list there. It's not comprehensive. We'll go through DeepLearning4j, but of course you can use Spark ML, Lib or Spark ML, like said by Matthias before, Smile, Big DL, Prediction.io, Hummingbird, and many, many others. If you do some research on GitHub, you will find plenty of them. Those that I put in this list are ready for production. So if you plan to use one of those frameworks in a real project, not just for fun, they are ready. So it's up to you then how to implement your system. Okay, let's move to the deep learning concept. I try to stay away as much as possible for math formulas. There is just one. So because that's important, because if you understand this concept, then it's a matter, we will see in a few minutes if the ID starts again, how it's easy in Scala to implement these things, because you don't have to reinvent the wheel. There are very high-level API to which you can design, build, test, evaluate your multi-layer neural network. So deep learning is a particular specialization on machine learning. Basically, it uses the pillars of the deep learning are multi-layer neural networks. We'll see the definition in a few seconds. So there is often you can find in the current literature that artificial intelligence, machine learning, and deep learning are used as synonym, which is wrong. They are not the same way. So artificial intelligence is some theory which is up since the 50s about it's started as a theory on assigning tasks to machines, to computers, tasks that usually can be done by humans. Then in time the technologies evolved, so in the last 10 years or 5 years there is much more data available to train your models, so they start to see some implementation of some of the problems that artificial intelligence will address. So machine learning is one particular specialization that basically, the goal of machine learning is to make machines to solve problems, make predictions from the data, not explicitly programming them. So usually when you have to implement an application in Scala, you write the code, you define the behavior of the application, and then you expect that whatever the input for that particular case, the application executes this, or raise an exception or an error, depending if some of the input is it's good or wrong. In this case, basically, it's all based on the training of the models. There are different ways of training your models. Deep learning is a specialization on machine learning, so are the same concept. The difference is that in this case, you just use multi-layer neural networks for your model, specialized on this particular branch. So this is good to address a lot of non-linear problems. The neural network is another concept that is around since the 60s. So as you can see, most part of the concept in machine learning and deep learning are very old. There are no significant changes in the theory since the middle of the 90s. The initial model was was a network called ANN, artificial neural network. And for each single neuron in a network, you had a model like this. So basically, a network expects some inputs. For each input, you could have different weights. And then the way you aggregate these inputs and weights is on the formula on the bottom of the slide. This is the only formula you will see in the slides. And then this is the input for a particular function called activation function, which implementation depends by the model you have for that particular neuron. This produces an output that could be the final output of your network or the input for another layer of your network. Multi-layer neural network basically extended this concept. Of course, it's, the implementation of the model of the neuron much more complex, but that slide gives you an idea. So in a multi-layer neural network, you have the first layer, which receives all of the external inputs, and it's called the input layer. Then you have a final layer, which is the output for your network, and a series of inner layers called nested layers, hidden layers. Basically, that's why it's called deep learning, because you can add more and more hidden layers to implement a more robust model that gives you much more accurate estimates of that particular problem. And this is exactly the same model, whatever the implementation is. Tied to this, there is also the concept of backpropagation to send back the errors generated at each level, but it's the same model for any implementation. I'm not going through all of the current variation implementation of multi-layer neural networks, because each of them is specialized on a particular class of problems. Today we are seeing an example in terms of image classification. So we will see an example of CNN, which is a convolutional neural network. If you see those images that I like so much, I found it on Wikipedia. So you have as an input an image, in this case is a robot, and then you have different hidden layers, which implementation could differ. So you don't have to implement all of the hidden layers the same way. So the first layer could be a convolutional layer, the second one could be a max pool, and so on. At the end, basically you narrow the scope to understand, for example, if the subject in the image is a robot or a human, or if you want to understand if a particular color is in that image, if there is blue, red, green, black, yellow, and receive as an answer true or false, and so on. Another common implementation of the, just for your reference, for multi-layer neural networks are the RNN, recurrent neural networks, and the case where they use this in natural language processing, but this is out of scope for this talk. Well, if you move to Scala, you don't have to reinvent the wheel. There are some good framework to use for this. The first one is Apache Spark, so probably I don't need to go through all of the details, because from the question before, I understood that many people know what Spark is and probably use Spark in production. Anyway, it's a fast cluster computing platform which processes data in memory across different nodes, and can work with different data storage. So the data could be in Hadoop, could be in NoSQL databases, relational database. Has support for 4 different programming languages: Scala, of course, and but also Java, Python, and R. But I discourage to use R anyway, because there is no full support for this, and other problems related to the parallelism model for R. So the best choice probably Scala, because in Scala you have full coverage of all of the APIs provided by Spark, but also good coverage for Java and Python as well. And this is the way job is executed in Spark. This is probably not the best example to show, because there is a single master, which is a single point of failure. But of course, in production, you don't have a standalone cluster. You can deploy Spark using Yarn. If you have some Hadoop platform in-house, you can use Mesos, or in the latest version, you can use Kubernetes. We are trying to use Kubernetes in Optum as a cluster manager on top of OpenShift origin. So Spark is not monolithic. You have a core library and then different libraries that you can add to your project just only if you need to use them. So there is Spark SQL to use dataset and put some sort of SQL, let's call it SQL layer on top of data that probably are not structured data originally. There is Spark Streaming, which includes both the traditional D streams and also the new paradigm, which is the structured streaming, which is much more powerful than D streams because allows also continuous streaming, and in terms of performance, it is better than the stream. So you're not tied to use the micro batches inside the stream. Then there are the MLlib, ML libraries, which provide some facility for machine learning. So probably your algorithm is already there. You don't need to add extra libraries. And GraphX is a library to handle graph data structures. So the second framework we are going to talk about is DeepLearning4j. It's an open source framework which basically brought deep learning in for the JVM. There is native support for Java and Scala, as integration out of the box with Hadoop and Spark, so you don't need to do some something from scratch if you want to use DeepLearning4j with your Spark jobs or whatever you have in Hadoop. And it has support both for CPUs and GPUs. You know, for some particular deep learning matters like image processing, image classification, you will need, in order to improve performances, to use GPUs, not just CPUs. And there is support out of the box, so you have already there the API, so you don't have to use third-party libraries or do something, implement something by yourself. If you browse the network, the internet, and you find some model which is perfect for your specific use case, but unfortunately that model has been implemented in Python, it happens, you can import anyway it in DeepLearning4j through Keras, which Keras is a separate open source project, but is used by DeepLearning4j to import those models. Then there are some API that act as a wrapper for that particular model, and you can then train, test, and change that model the way you need for your particular project. DeepLearning4j is not monolithic. There are different modules, and inside some of these modules there are different libraries. So when you add your dependencies through SBT, Maven, or Gradle to your project, you don't need to include whatever for DeepLearning4j. There is the DeepLearning4j is the core libraries for implementing neural network models. Then there are ND4j, which is supporting of the NumPy library for Python to the JVM. DataVec, that's important because there you have the API for to transform ingest data for training and evaluating your model. This is important because any model you implement in DeepLearning4j expect to have some tensors or multi-dimensional, single-dimensional array. So, but if you do, for example, image processing, the image is not by SF a multi-dimensional array. So you have DataVec, which does this transformation for you, provides a reader for different formats, and then the data ready to be processed by Deep4Learning and Spark, if you have Spark in-house. Java CPP is the bridge between Java and native C++ to do some particular operation when you have to do something which is specific for particular operating system. Arbiter is the evaluation tool when you are done training your model and you want to evaluate it. You can use this library. And RL4J is the next level of deep learning. So it's a library for deep reinforcement learning for the JVM, of course. But this is something that is still not the library. The concept is something quite new, is the future of deep learning. So there is a lot of theory on this space, but no concrete implementation. So I prepared some examples for, the first one is to show how your data could be transformed to be used by Spark and DeepLearning4j. And then I collapsed the other two examples to understand how you could build a CNN using DeepLearning4j and how it works with, in particular, in a case of image recognition. I need to open the source code because I had to reboot the machine. So let's use some notepad for this. And then this is one. This is the second example. Some of the example I'm going to show you will be part of the test we are doing with my team, and also some for the book. So some of them will be available in GitHub next week, and for other one will be available next, because we're doing a proof of concept of the later version of DeepLearning4j, which has been released 10 days ago. And it works with, it should work with Spark 2.3, so which is a particular interest for us. So yeah. ScalaUA. So the first example is good because it's simpler than this one. Let's see. It's coming up. Here it is. So this example basically shows how to use DataVec with the Spark. Where is the language? Okay. So probably this is better. So this is very simple to keep the, we'll start with a CSV file. So basically we have a CSV file with data coming, for example, from an e-commerce website. And you want to discover if there is some attempt at fraud on some transaction who happened between some customers and some merchants. And the structure for this file basically have a timestamp when that particular transaction happened. Then there are other columns which are the customer ID and the merchant ID. So some way you have a reference to all of the details to these entities. The number of items in that particular transaction. I hope this could be seen. And then there is the country code for the merchant. In this case, there are just 4 countries: USA, Canada, France. It's a small. So let me try to magnify it. Fortunately, the ID stopped. There was a way in this editor, but I don't know. Yes, probably here there is a zoom. Here. Found it. Okay. Let's do again. Okay. I hope it's better now. Oh, let's magnify a little bit. Yeah. Can you read it now? Yeah. Okay. So I think now should be better, but just in case, let's see. Okay, no, this is good. It's an optician test. So basically, there is also the country code, the number of transaction in US dollars, and a label which is probably an initial attempt to tag this transaction as is a fraud or not. So probably for your analysis, you don't need all of this data or need this format. So through DataVec, before creating the tensor, the arrays for your model, you need to apply some transformations. And there is a single class to do this. So it's the transform process class, this one, that does the magic. So whatever the transformation is, you just use the transform process, which is part of DataVec, and then define the transformation. And at this level, you just define the transformation. You don't apply anything. When this application runs, here, nothing happens, because when you move then to processing the data, this will be applied. In this case, there are just two transformation applied. The first one is to remove the columns related to the customer ID, merchant ID, just in case you don't need this data. It's possible to apply condition to filter the data. In this case, which is some of the cases we have in Optima, is to restrict the target to North America, so considering just the data that are coming from USA or Canada. And at this stage, basically, you define the output schema. So when you're going to handle this data, the schema of your data is not the original one, but it's the schema that you receive when you apply this transformation. At this stage, so here you can see we use just DataVec APIs. There is no Spark yet. Spark come now. So you define the transformation. Then you start a Spark. In this case, I'm using a Spark context because this is an old example which is compatible with the old version of Spark. It doesn't have support for the Spark session. But if you download the new version 1.0.0 of DataVec and DeepLearning4j, you can use Spark sessions. So in this case, you define the configuration for your Spark context. And then again, because this is an old version of DataVec, there is no support for some Spark Scala classes. So that's why you can see that there's Java Spark context and not the Spark context, which has been meant for Scala. But anyway, the rest of the application is the same, using the rest of the Spark Scala API. So at this level, you load the data. In this case, I have CSV files among the resources of the project. And then the first thing you have to do is apply the specific recorder for your input format. In this case, is a CSV file. So in DataVec, you have a CSV record reader. There is a record reader in DataVec for each format handled by the API. So each of the format you expect for deep learning purposes. So for example, for image classification, there is a reader for images for handles all of the most common image formats. And you can implement your own record reader. So these API are extensible. So if there is some legacy system, some legacy format, if you work with a big company, you will see a lot of them. And so you can implement your record using the same API. And then what happens next is the same using Spark and the rest of DeepLearning4j. So the first thing you do is to use this class, which is part of the DataVec, but basically execute the transformation of the data using the transformation defined before. So at the end of this, when I collect the data, this example is for a single node, so anyway, the data are locally. Basically, you will see that the output data are not the original records. So you don't have the merchant ID, the customer ID, and you filter all of the data by country, so just data related to USA or Canada. Same way for each kind of transformation, including the transformations available in Spark, you apply them the same way. So for, as you can see, if you're familiar with the Spark API, there is almost nothing new, just the way you handle the data. Of course, there is support for streaming, typically in a machine learning or deep learning training process, you work with data at rest, so you don't get incoming data, so work with some big database that could be in Hadoop or some other storage system, but there is support for streaming as well. So if you have Kafka Spark streaming in your infrastructure, you can do the same with different APIs, but through DataVec and DeepLearning4j. And this is general for any problem you address with DeepLearning4j in whatever is your scope and whatever the model you're going to use, if it's a CNN, RNN, or a different neural network implementation. Going to the other example, basically in this case, this is an example of image classifications. So a model that has been trained starting from a database which is available on the web, is this one by Digital Media. So there are images of 4 particular animals. There is cat, bear, tiger, don't remember which one. And basically through this data you can train your model, and then you can validate your model as well and start to use it, pushing an image, say, okay, this animal is a cat, or is a bear, or is a human, or is a chair, or whatever. So it's not an animal. Let's go to the principal part of this code, the way you first load the data here. As you can see, there is an image record recorder, which is part of the DataVec library. So you can see it's quite the same we did a few seconds ago for the CSV file. There is a specific record reader, and again, use this class to load the data to your model. In this case, there are multiple images in the original database, so you set up an iterator to go through them to train your model. And then you can imagine in this case that basically you had in mind some model, but you don't know yet if it's good or bad, so you need to train it with this data. And this is the way you train the model. So there is a dataset iterator, which is part of one of the sub-libraries of DeepLearning4j, which is specific for CNN. And then after this, you start to train the model. When you're done with training, basically you can evaluate the model. So basically, in the initial dataset, you reserve some portion of the data for testing. And again, you use the same API to evaluate the model. And when you're happy, you say, OK, it's gone, so I'm completing this. Last but not least, what's the way you implement your model inside this code through DeepLearning4j? So let's move to the bottom here. In this source code, there are 3 different implementation of CNN. Let's observe this one, which is the simplest. So basically, there is this class, multi-layer network, which is part of the DeepLearning4j NN library, which is the same class you use for any implementation of a multi-layer network. Inside this class, there are facilities to basically build this model from scratch, set up all of the needed parameters. I'm not going through all of them because this requires to write also probably some formula. It's important, this is the part that probably could be interesting to show. Then you set up a list of layers. So it means in this part of code, you define how many layers your network should have, what's the input layer, and what's the implementation of the input layer, what's the implementation of the output layer. So layer 0 is the input layer. Layer 5 here is the output layer. All of the layers in the middle from 1 to 4 are the hidden layers. And as you can see, there are different implementations for each of them. So level 1 and 3 are max pool hidden layers, while layer 2 is a convolutional 5 layer. And of course, in a more complex neural network, you have multiple hidden layers with different implementation, and you can use your custom implementation for this, and I will show you how you could do this. Oh, yes, there's one. For example, for any convolutional layer, you have this particular class, which is convolutional layer, which is part, again, of DeepLearning4j neural network library, and then pass all of the configuration. So basically what you have to do, you have to take a piece of paper, think about your model, and then set up the parameters, the expected configuration using this class, whatever the implementation is. So there is support for all of the available implementation of a hidden layer for a convolutional neural network. There is a separate class for RNN or different implementation of other neural network. So as you can see, basically, if you are strong in Scala, like you are, and you want to move to this space, basically the effort is to upskill in terms only on the concept behind deep learning and machine learning, and then you have a lot of facilities, so you don't have to reinvent the wheel. So if you want to implement some convolutional layer, you just use that particular API and put all the things together in some Spark job or some util classes which work with that particular Spark job. So that's why, coming back to the initial goal of this talk, why Scala is a good fit for data science, because there are plenty of tools that you could use, and you just import there the skills you have in Scala, and all of them will be useful there. I put some links in the slides about the open source framework used. I put a link to Keras as well, just in case you find in the web some interesting model in Python and you want to play with it in, with DeepLearning4j. And before moving to the question, just say thank you, and put also the reference to my contact for any questions the next days, whatever. The slides will be available on my slide share space in the next days. In a couple of weeks, you will have also the examples and some other insight that I'm doing for the book as well. I'm in depth. I have to put on my GitHub space also some things from other two conferences, but stay tuned and reach me just in case you want to learn more or have more tips. So, questions?
Do you have some use cases of this system? I mean, have you conducted some experiments using this recognizer?
Yeah, basically, the company I work with has a project in whatever is healthcare, including some classification of diagnostic images. So the teams in my area are much more made by software engineers specialized in big data, and they are setting up an infrastructure which includes DeepLearning4j, and then the machine learning teams, where there are more data scientists there than software engineers are using the platform and helping us to validate this. This for image classification. For other matters, we are using DeepLearning4j because I didn't mention what's the main scope of the business area where my teams work at the moment. So we are in the area of fraud, waste, abuse detection for the prepay and post-pay phases of the claim processing, because the company has a lot of customers across the United States, Canada, and Brazil for the insurance company. There are a lot of cases of fraud, waste, and abuse. There are some masters of this in the United States. And so basically we are doing deep learning to identify these potential cases in the prepay phase, because at that stage is the phase where the company didn't pay yet the provider or the customer for the money they are claiming. So there is no money lost for the company, while in the post phase, which is what happens now doing manual processing, if you spot some attempt of fraud, then you have to chase the customer or the provider. Sometimes it was a fake profile or a person that doesn't exist, or who stole some identity. So that's where we have something in production. I cannot share the details there, but that's the first business case we did. We have in production using DeepLearning4j, of course, Spark.
Thank you.
There are the people there.
Hello, thank you for your talk. You said that there is an option to import a model from Python, but you said like in general from Python. And then you mentioned Keras. Keras provides you with capabilities to specify a model, but it uses TensorFlow or Theano as backends. Can we also export TensorFlow models into DeepLearning4j?
Yeah, Keras, basically the first pilot of the Keras project has been with TensorFlow. I think there was some support by Google. So if you have something implemented in TensorFlow or something in Theano that is going to disappear, it's pretty straightforward.
And the output would be like trained model or like weights format or like Scala code for the like network itself?
Oh, on the other side, from your side, it would be just Scala. So basically, it's the original model is wrapped into Scala or Java, depending if you're using it. Yeah, yes, that's the real value of using Keras to import models.
Thank you for your talk.
Welcome.
I wanted to ask about performance. What about performance comparable to TensorFlow or something? And another question, does it support GPUs? Calculation in GPU?
Yeah, to answer your second question, there is support for GPUs because one of the libraries that I mentioned before basically is specific for GPUs. And anytime you start new code, there is a parameter to say I want to use just CPU or GPUs or both. And in terms of performance, it's basically that depends. But if you use DeepLearning4j on top of Spark, so whatever you have in terms of performance is working with a big amount of data, like in the case of Optum for the health insurance company. So it's are very good. So in terms of training the models, we did some experiment also with streaming, and the performance are pretty good, not just static training. So all of the data sheet you see about Spark performances apply the same, because the company that there is a company that started this open source project. They provide the same project available in the cloud as a commercial offering. So since the beginning, they start to having in mind performance using DeepLearning4j with Spark for big data volumes, and that's why the performance since the old version are really good.
Question. So there are many interesting use cases for image recognition, right? And like one of them is like search by image, something like that. So I'm just wondering, like, let's say I'm a software engineer, like, and I have no clue about like deep learning or any of that stuff. Is there a way for me to say like, oh, here's my like database of images, like tigers, bears, like whatever. Please process that, and please give me like a service. Here's my image. Please search something. So something like which I can treat as a black box. And what would be a problem if someone will try to provide functionality like that?
Oh, basically, if you browse the documentation of DeepLearning4j, so because the guys that did this project are mostly software engineers, so they started to think of this problem from a software engineer perspective. So basically, whatever API they implemented has been meant to be used by someone which is strong in software engineering, but has a very little knowledge on data science, machine learning. So you could start to think of some use case and say, oh, I have this set of images. These are the questions I want to answer. And then it's easy to build some very basic model from scratch. Of course, for most complex things, you will need some help by some data scientists. But anyway, there are...
yeah, so my question is kind of like, if I don't want to touch like science and learning, whatever, like I'm saying like, oh, this is like services, some server, like, yeah, I can scale it, I can do like all infrastructural stuff, but like, here's my data, here's another piece of data, please classify. What would be the problems like which like will prevent someone to do something like that, or like?
The problem could be if you use just DeepLearning4j and nothing else. If you have DeepLearning4j on top of Spark, you have much more facilities for this. So because the framework has been meant to have good performance to design models, train models, and import models. But then when you say, okay, I want to move this to production, you need to use Spark for this, and then you have a lot of services saying, okay, this is my data source. I collect data or data sources and do some streaming or batch, and then you have everything is there using altogether DeepLearning4j and Spark.
Okay, but you're not aware of any of kind of like builds like that? I mean, like any assemblies which like will produce something. Oh, here's the out-of-the-box working solution.
No, so far we encounter any. So
thank you.
There is another question over there.
Hi. What do you use for model orchestration in production? For example, monitoring, model iteration, monitoring, etc.
Basically, at the moment, we have different tools in production. I can't discover the details because this is one of the things that my company prevents to. But basically, we have just give some clue. One of the question we have is about the quality of the data, because if you have some data that are bad, of course the model trained with the bad data would be a bad model. So we use one tool in that case which is open source, and it's called Streamset Data Collector, where you can define rules about the data quality, and this basically applies to all of the data sources for a particular model, because in some cases, for example, for image classification, you have just diagnostic images, but we're trying to apply the same on some cybersecurity matters, and then you have data coming from different sources, different formats that together, pulled together, give the same picture, different picture of the same event. But coming from those systems, there is a lot of noise. So in that case, we use this to filter and understand the quality of the data before sending the data to the models.
Okay, thank you.
Okay, thank you. We are out of time, so you can continue your questions
Offline.
after.
Thank you. Thank you, guys.